Chapter 5, Polynomials and Polynomial Functions. Sections 5.1 and 5.3, using properties of exponents and adding, subtracting, and multiplying polynomials. So before we start getting into the properties of exponents and you try to start memorizing what the properties of exponents are, let's take a look and think about what exponents mean. So if I have x to the third times x to the fifth, I could write out my x to the third, and I could write out my x to the fifth, and then you could see that I could actually condense these, and they would be x to the eighth. When I have x to the third to the fifth, the first thing I want to take care of is that 5, which means I'm going to write out x to the third 5 times, and then each of those x to the thirds, remember, is x times x times x. So if I write all those out, and then I can see that I could condense this as x to the 15th. So when we think about the properties of exponents, first of all, I want to make sure that you're aware that I will never ask you to tell me what the power of a power means. These names, I just want you to understand what the properties of exponents are. So the first one, if I have a to the m times a to the n, well, let's think about what if m and n were numbers. We just did this on the previous slide. It's x times x times x times x times x, which I could condense as x to the fifth. So what did I do to those original exponents? I added them together. The next one, if I have a to the m to the n, well, again, if we remember what we do when we actually have numbers in there, we take care of the squared, and if we were to write all those out, I would end up with x to the sixth. And again, what did I do to my original exponents? I multiplied them. And finally, if I have a times b to the m, well, that would be like if I have xy squared. That means I'm going to write out x times y times x times y. Using the commutative and associative properties, I can group my x's and group my y's together and end up with x squared y squared. So this would be the same as a to the m times b to the m. I'm raising everything in the parentheses to that power. Now, you need to be aware, especially on this last one, that a times b are being multiplied in the parentheses. If this was a plus b, you could not just raise everything in the parentheses to that power. So if you think about what these properties mean, if you were to write them out, they're a little bit easier to remember rather than just trying to memorize what these properties are. So if you get stuck, think about what it would look like if you wrote everything out. Negative exponent. So if you were to put in your calculator, pause the video for a second and put in your calculator 2 to the negative 1, well, that's going to give you 1 over 2, or your calculator would give you 0.5, which is obviously 1/2. So what this means is we're going to take that negative exponent and put it in the denominator and make it positive. Similarly, if you have a negative exponent in the denominator, you would put it in the numerator and make it positive. If we have a zero exponent, take your favorite number, raise it to the 0 power, and what do you get? It's not 0. It's actually 1. So anything raised to the 0 power is 1. No matter how complicated something gets, as long as the whole thing is being raised to the 0 power, it will be equal to 1. And our last two properties deal with division. So if I have a to the m over a to the n, so that would be like x to the fifth over x to the third. And if I write out all the x's on the top and all the x's on the bottom, keeping in mind that x over x is 1, so just multiplying by those 1s, I can kind of cancel those out, and I'm left with x squared. And so what did I do to the original problem to get x squared? I subtracted my exponents. So you need to be careful, or not necessarily be careful, but be aware also the way I prefer to think about this is if I were to write these out and get rid of my factors of 1, this ends up being 1 over x squared. And so the way I look at this is, where do I have more x's? I have more x's on the denominator, 2 more x's, so I get x squared. This would be the same as subtracting my exponents. You would end up with x to the negative 2, which then we need to write as 1 over x squared using our properties of negative exponents. And finally, power of a quotient. So again, if I have x over y to the third, and I write this out 3 times, I'm going to end up with x to the third over y to the third, which means I'm raising everything in the parentheses to the third power, or in the case of the generalization, everything in the parentheses to the m power. So now let's get to some problems. Most of the time, these properties of exponents problems have more than one way that you can attack them. So to begin with, I could take -3, making sure that I keep that -3 in parentheses, to the third power, and 5 to the third. -3 to the third is -27. 5 to the third is 125. Multiply those together, and I get -3,375. I could also take care of what's inside the parentheses first. So -3 times 5 is -15. To the third power is, of course, -3,375. If I have a problem like this, again, there's more than one way you could approach it. So 2 to the third and 3 to the second would be 8/9. It's still being raised to the -2nd power. Taking care of that negative exponent as a fraction, that simply means that what's on the top goes to the bottom, what's on the bottom goes to the top, and my exponent becomes positive. From there, 9 to the second is 81, and 8 to the second is 64. Another way I could do this is raise everything in the parentheses to that negative power, so that becomes 2 to the -6, 3 to the -4. Then take care of my negative exponents, and 3 to the 4th and 2 to the 6th will still give me 81 over 64. Example 3. So the properties of exponents say if I'm multiplying the same base number together, being raised to the power, I could add those exponents. So when I add 5, -8, and 6, I get w to the third. I could also look at this and say, well, I need to take care of that negative exponent, so I'm going to put the w to the 8th on the bottom. Simplifying my numerator, I get w to the 11th over w to the 8th. Where do I have more w's? On the numerator, 3 more in fact, so I would get w to the third. In this example, I can take care of my negative exponent inside my parentheses first, so it would be c times d to the 4th to the -2. Now I could take care of the negative exponent and put all that on the denominator, and then raise everything in the parentheses to that second power. The other way I could do this would be to raise everything in the parentheses to the -2nd power, then take care of my negative exponent. Either way, you end up with the same answer. And so now we're starting to get a little more complicated, more things going on. So the first thing I would do is take care of my negative exponent, and I'll put that a to the -3rd on the bottom. Then I can simplify all my a's on the bottom, so I'll get b to the 2nd over a to the 8th. I'd challenge you to pause the video and try to do this problem on your own first, and I will kind of zip through and do it the 2 possible ways you could look at this problem. So to begin with, I can take care of my a's. I have more a's on the denominator, so I can write this as 1, or not 1, but 2a on the denominator. My 2 stays on the denominator. Then I'm going to take care of my negative exponent. So I still have the b squared on the denominator, because it's a positive exponent, but my b to the 1st is going to go to the denominator. And now I don't have anything on my numerator. So that's where I'm going to use 1 as that placeholder, because I need to have something on the numerator. It's still all to the 3rd power. When I simplify my b's now, I'm going to get b to the 3rd on the denominator. Still everything is being raised to the 3rd power. 1 to the 3rd is 1. 2 to the 3rd is 8. Be aware that we're not multiplying, it still is going to be 2 to the 3rd. So 2 times 2 is 4, times 2 is 8. And a to the 3rd, and then b to the 3rd would give me b to the 9th. Again, this last example of this kind, I challenge you to do it on your own. Oh, I'm sorry, this isn't the last example, it's the second to last example. Let's take care of those negative exponents. And then we're going to take care of our y's. I've got more y's on the denominator, so the 7 stays on the numerator. It becomes y squared on the denominator. And then where do I have more z's? on the numerator. 4 more, so it would be z to the 4th on the numerator. This is the last one of this kind. So first of all, 4/6. Keep in mind that property of exponents deals with just exponents that you would subtract. This is simply 4/6, which simplifies to 2/3. My a's, neither of those are negative, so I have more a's on the denominator. It would be a squared on the denominator. And then I'm going to take care of my negative exponents, so to the b to the 4th on the bottom and b to the 2nd on the top. Now I can simplify my b's. My 2/3 a squared stays where they are, and I have more b's on the bottom as b squared. Adding and subtracting polynomials should be reviewed to some extent. You're just adding and subtracting like terms. So when I combine my x to the thirds, I get negative 1x to the third. When I combine my x squareds, I get positive 2x squared. When I combine my x's, I have negative 7x, and my numbers give me 6. I tend to cross things off because then when I'm done combining my like terms, I can look back and know that, yes, indeed, I've added everything together that I need to, and that's my final answer. You should pause the video right now and try to do this problem on your own, and I will just pop up the answer, and hopefully you'll get the same thing. When we're subtracting polynomials, you need to make sure that you're distributing that negative. Remember, that's like a -1 in front of the parentheses. So when I distribute the negative, obviously everything is going to change signs. And then again, it's just a matter of combining my like terms, the x cubes, the x squareds, the x's, and the numbers. Again, everything is crossed off. I've used everything up. That's my final answer. Again, I'd like to challenge you to turn off the video or pause the video and try to do this problem on your own to make sure that you get the same thing. Distributing the negative changes all the signs. Combining my like terms gives me negative 3y squared plus 2y plus 20. And finally, the last topic would be multiplying polynomials. Remember that you need to multiply everything in the first parentheses by everything in the second set of parentheses. So a lot of times it's helpful to draw the little lines. So I get 6x cubed plus 9x squared. Now you can write these out all in one line. You could also stack them, and it makes combining your like terms a little bit easier. This would give me a 6x squared and 9x. And finally, distributing the 5 gives me 10x and 15. Now just doing basic your column addition, I'm going to get 6x cubed, 15x squared, plus 19x plus 15. When you have 3 sets of parentheses, you can only multiply together 2 things at a time. So the first thing we're going to do is multiply together the x minus 1 times the x minus 1. When you do that, you'll get x squared minus x plus 1. Don't forget that we're still multiplying it by the x plus 2. To make things a little bit simpler, I would combine like terms first. And then again, you need to multiply everything in the first parentheses by everything in the second parentheses. Again, I did it in the column fashion. Combining all my like terms, I get x cubed. My x squareds cancel out, a positive 2x squared and a negative 2x squared. My x's and my 2's. So I get x cubed minus 3x plus 2. This is one of the problems that I alluded to earlier. I have a plus inside the parentheses, so I cannot simply say that this is 16a squared plus 49. You need to make sure that when you have addition or subtraction inside your parentheses, you write out 2 sets of parentheses and actually multiply them out. Combining like terms, I get 16a squared plus 56a plus 49. This last one's a little bit tricky. I really would like to challenge you to pause the video and do this on your own. You do have to write out 3 sets of parentheses, and you need to multiply the first 2 sets of parentheses together first. So go ahead and pause the video, and I'm going to just kind of cruise through this. Combining like terms, And now I need to multiply everything in the first parentheses by everything in the second parentheses. Adding all my like terms together, I get m cubed n cubed minus 18m squared n squared plus 108mn minus 216. And that concludes sections 5.1 and 5.3. If you have any questions, please make sure you come to class and ask them.